Hello, good afternoon. And in this session, we'll see some MIT Integration B finals integration questions. Those who are preparing for JEE mains or advanced can also try their hand on these problems. They are really wonderful. So let's begin with the first problem. So here I need to integrate square root of tan x into square root of 2 plus square root of 4 plus cos x. So of course, as per the standard integration methods, we know that this guy should be taken as the substitution because root of x integration I know. When this turns out to be a variable, but then here it's not. That means this guy must be a substitution. So let square root of 2 plus square root of 4 plus cos x is equal to t. So in the next step, I'm going to get 2 plus square root of 4 plus cos x is equal to t square. So after this, we get here 4 plus cos x is equal to t square minus 2. Now let's again square this. So I'll be having 4 plus cos x is equal to t square minus 4. No, not t square, t power 4 minus 4t square plus 4. That's what we get. And here this 4 and this 4 gets cancelled. So we are left with root cos x is equal to t power 4 minus 4t square. And now if I look at this, then my integration has tan also. So tan I could write sine over cos. So if I rewrite the original question like this, sine x over cos x into the square root of 2 plus square root of 4 plus cos x dx. The cos x I already have got. So if I differentiate this equation, so I get my sin x and dx also. So I'll consider differentiating this guy. So I'll be having, so differentiating 1. So in that case, I'll be having minus sin x dx is equal to 4t cubed minus 8t then dt. So we successfully have obtained everything, I guess. Now let's plug in everything here. So sin x dx we have got here minus of 4t cubed minus 8t. And then this guy we already have taken as t. And cos x we have found it's t power 4 minus 4t square. Then sin x dx is 4t cubed minus 8x. Already we have written, just we need to write dt. So this works, and now I think we can take something common. So yeah, let's see. I can take 4t square common. So this gives me t square minus 2. And here outside we have minus waiting. And from the denominator, I could take again a t square common. So this gives me t square minus 4 and then dt. So for me, I could cancel this. And then now I'm left with uh, minus 4 times integral t square minus 2 over t square minus 4 dt. And to simplify this, we could write t square minus 4 plus 2. And then we have here t square minus 4 dt. This could be further written as minus 4 and then 1 plus 2 over t square minus 4 dt. So I could write here minus 4 integral dt minus 8 times integral 1 over t square minus 4 dt. So this would give me minus 4 t minus 8, and this is our standard problem. So 1 over x square minus a square type. So this gives me 1 over 2a. Then log of x minus a over x plus a. I could use this. So I'll be having here 1 over 2. A turns out to be 2 here. Then log of t minus 2 over t plus 2 plus c. Now we can resubstitute t. So resubstitute t. And this gives me minus 4 square root of t we had taken is root 2 plus root 4 plus cos x. Root 2 plus the root of 4 plus cos x minus 4 times again. No, it's 2 times. So 2 times log of plug in t there. So that will give me 2 plus root of 4 plus cos x, then minus 2. And here also the same thing. So root 2 plus root of 4 plus cos x plus 2. Then plus that completes off this first part. Let's go for the next one. So coming to the next one. So we have integral 0 to infinity and x plus 1 plus 2 times the root of square root of x. So this bracket here for us means it denotes floor of x. And for those who are not comfortable with floor, they must be knowing something called as GIF of x. So it's same as the usual thing as greatest integer less than or equal to x. So greatest integer less than or equal to x. This is what we mean. So now we need to integrate this from 0 to infinity. So the standard procedure, I think everyone knows. We'll try to break this at every point where in this domain, we're going to break it at every point where this becomes an integer. So now we have box of 2 root x. So here I'll consider because I need to find the point where I have to break this. So let box of 2 times root of x is equal to some integer n. This one belongs to integer. And since this is 0 to infinity, so it's going to be z positive. Union 0 also is possible. So now square. So when I'm saying that box of this is equal to n, that means this quantity inside lies between n and n plus 1. For n belong to integer plus union 0. So now I need to find out x because I have to break x from that domain. So I'll square this. So n square is less than or equal to 4 times just x is less than n plus 1 square. So if I just divide by 4, so I get n square over 4 is x less than or equal to n plus 1 square over 4. So that means I need to break it at every point where n becomes positive integer. That means starting from 0, I have to start with 0 to 1 by 4. And then similarly, next will be 2 square by 4 to 3 square by 4. All these points I have to break. So for that purpose, now what I'll do, I'll consider this to be summation and starts from 0 and then goes to infinity of the form n square over 4 to n plus 1 the whole square by 4. And then I have here 1 over x plus 1 plus, just for our convenience, we'll write down box only so that this gives a clear message. And now if I consider these things, so from sigma starts from n is equal to 0 to infinity, between n square over 4 to n plus 1 square over 4, we have found that this gives integer just n. So I could write here n square over 4 to n plus 1 square over 4. This is going to give me just x plus 1 plus just n squared x. So we have taken the same thing. And now if you see this, simply quadratic squared. So to that regard, I could write n is equal to 0 to infinity. And then this integration would be simply minus of 1 over x plus 1 plus n. the limits are going to be n square over 4 to n plus 1 square over 4. And now the actual game begins. So we'll plug in here n plus 1 square over 4, then n square over 4. And since outside we have minus, so what I'll do, I'll just plug in the lower limit first. So I'll be having n is equal to 0 to infinity 1 over n square over 4 plus n plus 1. This minus 1 over, okay, let's plug in n plus 1 square, so n plus 1 square over 4, then plus n plus 1. And this is what I get. And now I have to begin finding the sum of this series basically. So let's take it to the other page and then solve that. So let's go ahead, and then now this gives me basically sigma n is equal to 0 to infinity. I can just factor this 4 out and write down directly here 4 times. Then this gives me 1 over, this is n square plus 4n plus 4, which is nothing but n plus 2, the whole square, minus 1 over, and this will give me n plus 1 square, and then 4 times n plus 1. So we can take n plus 1 common. So this gives me n plus 1 into n plus 4 plus 1, which is n plus 5. And that's what we get. Or we can separate this because both the series are convergent. So 4 times sigma n is equal to 0 to infinity. Yeah, it's 1 over n plus 2 square minus 4 times sigma 1 over n plus 1 into n plus 5. Now, if you look at this guy, so I can plug in here 4, and then let's write down there 0. So 1 over 2 square plus 1 over 3 square plus 1 over 4 square, and so on, minus 4 times. Oh, we can take this 4 inside and then perform the telescope. So 4 I'll be writing this way. Because you see here, this is n plus 1, this is n plus 5. So 4 I could write n plus 5 minus n plus 1. So n gets cancelled, and then 5 minus 1 gives me a 4. So I get the same part. So n plus 1 into n plus 5. Now, for this thing, we need to know the Bessel problem. So Bessel problem is 1 over n square, starting from n is equal to 1 to infinity. So this gives me pi square over 6. Okay. So if I use this thing here, so n starts from 1. So if n is from 2, so I need to write down one more term here. So this gives me 4 times pi square over 6 minus 1. Because my n starts from 2, so this 1 I have to subtract. So I begin pi square over 6 minus 1. Minus what this guy is. So sigma 1 over n plus 1. And then minus 1 over n plus 5. I'll call this equation star, and I'll consider only this much. So consider sigma 1 over n plus 1 minus 1 over n plus 5. So this gives me n starts from 0 and then goes to infinity. So let's plug in the telescoping thing. So n equal to 0 you plug in, so 1 minus 1 over 5 plus, when I plug in 1, so I get here 1 over 2 minus 1 over 6. And then plus plug in 2, so 1 over 3 minus 1 over 7. Sorry, 7, and then plus 1 over 4 minus 1 over 8 plus 1 over 5 plus 1 over 9, and then so on. So we notice that this starts becoming the telescope after this 1 upon 5 gets cancelled. 1 over 2 survives. 1 over 6 will also get cancelled in the next part. So we are left with 1 plus 1 over 2, 1 over 3, and 1 over 4, post which everything gets cancelled. So that means I get here series n is equal to 0 to infinity 1 over n plus 1 minus 1 over n plus 5 will give me 1 plus 1 over 2 plus 1 over 3 plus 1 over 4. So the LCM turns out to be 12. So I can just simply write on there 12 plus 6 plus 4 plus 3 over 12. So this gives me 12 plus 6, 18 plus 4, 22 plus 3, 25 over 12. And now I can just write down all these things here. So the final value would be, so therefore, this integral 0 to infinity 1 over x plus 1 plus box of 2 root x square dx will be equal to 4 times pi square over 6 minus 1 minus 25 over 12. So this gives me 4 and this thing gets cancelled. So 2 pi square over 3 minus 4 minus 25 over 12. So this gives me 2 pi square over 3 minus 12 into 4 is 48 minus 25 is 73 over 12. So stay tuned for the next other three problems. That's all for today. See you. Thanks for watching. Bye.